Of the three measures of central tendency covered in this video, the mean is used most commonly. People often have the mean in mind when they use the term average, but the word average could refer to any measure of central tendency, so it is better to use the term mean. You probably have seen this mean many times. It is a statistic we often encounter in everyday life. It is computed as the sum of all scores, divided by the number of scores. Consider the earlier example of 15 test scores. If you sum all the scores and divide by 15, the mean exam score is about 91.07. This tells the instructor that the students generally performed well on the exam, though of course some scored higher and some scored lower. Notice that the variable must be measured on an interval or ratio scale in order to calculate the mean. Remember that it doesn't make sense to add nominal or ordinal level variables, so we cannot calculate a mean for those variables. Now, as common as it is important to be aware that the mean is not always the best measure of central tendency. It can be influenced by outliers, or scores that are markedly different from the others. For example, suppose that one student from our earlier example did not prepare for the exam and received a very low score. If instead of an 82 this student scored a 10, the mean would be 86.27 instead of 91.07. The mean can be greatly affected by just one outlier, which then makes it less representative of the distribution as a whole. When a dataset has outliers, other measures of central tendency may be more appropriate. One alternative is the median, which is the value at the midpoint of a distribution, that is, the score or value that divides the distribution into two equal-sized halves. Using the same set of exam scores, we would find the median by ranking the scores lowest to highest and then finding the middle score. In our example, the median is 93. The median is useful when there are outliers because it is relatively resistant to the influence of extreme values. Imagine again that the first person in the set had an exam score of 10 rather than 82. Whereas the mean was greatly affected by that change, the median would remain unchanged. The median is appropriate for ordinal, interval, and ratio level data, but not nominal level data. For example, we may use the median to describe the central tendency of variables such as socioeconomic status, SAT score, or income. A third measure of central tendency that can be used with all levels of measurement is the mode, which is simply the most frequently occurring score in a set of data. For our example data, 94 is the mode because it appears 3 times, and no other score occurs more than twice. The mode is not affected by outliers, but the degree to which it represents the typical score can be affected if the distribution of scores is asymmetric. If most scores occur around the upper end of the distribution, which we call negative skew, or if most occur at the lower end, which we call positive skew, the mode will be less representative of the center of the distribution. For example, if an exam is so easy that most people have high scores, or if the exam is so hard that most people have low scores, then the mode will not accurately convey the center of the distribution. It may help you remember which type of skew is negative and which is positive if you think about which direction the tail of the distribution is pointing. If it points to the left, toward the negative end of the number line, the distribution is negatively skewed. If the tail points to the right, toward the positive end of the number line, the distribution is positively skewed. Notice here that negative skew pulls the mean value toward the lower values at the left end of the distribution. With positive skew, the mean is pulled toward the larger values at the right end. In both cases, the median marks the midpoint and the mode marks the peak. Skew affects the mean the most, relative to a symmetric distribution like the one shown in the middle. Finally, also note that a distribution can be bimodal, or even multimodal, if instead of a single peak it has 2 or more peaks. In such cases, reporting a single mode for the data set may not be a good measure of central tendency. This is another reason why it can be so informative to graph data. If a researcher merely calculated the mean, median, or mode of this distribution, they would never know that it was bimodal.